Hello, my name is Chris Barton, and I'll be presenting the data quality section of this exploratory data analysis. So during this portion of the presentation, we're going to look at the quality of the data. This is important for a few different reasons during this particular study. One is because that the data is constructed from a number of A/B tests, and we need to make sure that nobody in the control group was exposed to the treatment. Two, as mentioned, this data set was constructed from a number of A/B tests, so we need to make sure that the features are independent of the test and control. And then finally, because this data was provided by Criteo, it has been anonymized and projected into a different vector space. For that reason, we need to make sure that the features that still hold predictive power. So the first sanity check is fairly straightforward, as Criteo provided a column for the treatment, which is a binary column. 0 is the control, and then 1 is the treatment group. And then they also provided an exposure column, so 0 if they didn't receive an exposure and 1 if they did. So for this, we simply write a SQL statement where we set the treatment to 0 and the exposure to 1 and do a count star. And if you run this in our database, you can see that 0 people who are in the control group received an ad exposure. In real life, this might be a little bit more difficult. You'd have a lot more questions to ask than simply running the SQL. You'd have to think about maybe is the person in multiple browsers? So how do you handle somebody who's browsing your website on their phone and then go home on a desktop? And then, they might be, one browser might be in the control and one browser might be in the treatment. Also, you might look at confounding variables such as, is this person in a different A/B test for a different, marketing group, such as, like maybe an email campaign, where that could affect their response rate. So you'd have to think about those questions in real life. Maybe to address those, especially for the second case there, you could put, if they are exposed to a different marketing campaign, you could use that as a feature and make sure that it's evenly distributed throughout the test and control groups. Moving forward, the next point is to make sure that the features that we're going to be used to predicting the outcome, which is conversion, basically are evenly distributed throughout the test and control group. In order to accomplish this, we're going to be performing a classifier 2 sample test. Basically what this does is you train a classifier on the treatment variable. So again, it's a binary variable, 0 if it's the control and 1 if it's the treatment. Once you train that classifier, you record the loss of that classifier. And the idea is that the loss of this classifier should be no better than a random classifier. So once you have the loss of the classifier that's trained on the treatment, you then create a baseline classifier, which basically predicts randomly the treatment variable based off of the proportion of the people who were treated and the control. And then we repeat that a bunch of times, about 500, to get a good distribution for that random classifier of loss. Below here we can see the results that the loss of the classifier trained on the treatment variable of the full data set was about 15.4%. And the average loss of the classifier trained with a random baseline classifier was about 15.4% as well. Below here we can see the results of the t-test. Here the distribution is the loss from the random classifier. The red line is the loss of the trained classifier in the data set, and the black one is the average loss of the random classifier. And here we fail to reject the null hypothesis, where the null hypothesis is that the loss from the trained classifier came from the same distribution as the random classifier. Moving forward. So finally, we want to make sure that the features that we collected do actually hold predictive power. In this case, this is actually very important because, as Criteo mentions in their paper, they have anonymized these features, so we don't actually know what they mean, number one. And then number two, they projected these features into a different space. So we can't even maybe make a guess about what they mean because they're not represented. This distribution that they now hold is not the same as it was originally. So in order to do this, we're going to do something very similar to the classifier 2 t-test. Basically, we're going to train a number of classifiers on the conversion variable, which is the one we want to predict. We're going to train one on the whole data set, one on just the treatment portion of the data set, one on the control portion of the data set, and then we're going to compare that to a baseline, which randomly predicts the conversion variable based off of the proportion of how often it occurs, and it's a binary variable. So here, after we trained the classifiers, we can see the Hamming loss, which is basically the percent of predictions that were wrong for each of these classifiers. So for the whole data set, 8% were wrong. For the treatment, 7% were wrong. For the control, 26% were wrong. And then for the baseline, 47, which is close to about 50% were wrong. So we can see a significant improvement in both in the whole data set, treatment, and control. Then we can just look at the log loss improvement over the baseline. And based off of the improvement, we can pretty confidently say that these features that we're modeling on do hold predictive power. So those are the three tests we use to kind of ensure the data quality, and to kind of do sanity checks to make sure that this data set is properly randomized and that the features are good to go and hold predictive power. Moving forward, we have the data pre-processing step, which thankfully, because this data set was prepared by Criteo, there's not a lot of stuff we have to do for this. We might, end up doing something like clustering or adding additional variable, but it's not like we're doing anything like natural language processing where we have to represent the data as a bag of words and then then further represent it with maybe some word embeddings or anything like that. So that portion of the project will be pretty straightforward. Finally, for next steps, we have a number of survey papers around Uplift modeling that we're going to read. If anybody's interested, those can be found in the homepage of the repository. And then we'll begin modeling. Modeling basically has two main approaches. The two-model approach, where you train a model on, you break the data set into a treatment group and a control group, and you build two models, one to predict the conversion variable for the treatment, and one to predict the conversion variable for the control. Once you have those models, you subtract them to come up with the uplift. The other modeling approach is the class transformation method, where you basically go through some logic where instead of having two models, you basically transform based off some series of logic that we'll go over later, the treatment variable and the conversion variable into one variable that you can use to just train one classifier. And that is it for our exploratory data analysis phase. Thanks for listening.